Okay, today we'll start with regression analysis, first part. In previous class, we have studied about correlation. Within two parts, we have finished the correlation part. Now, from today, we'll start the regression analysis for the statistics for engineers course. Okay, actually, we are try to review the regression analysis. Okay. This actually explain the linear multiple regression models, interpret the linear multiple regression, compare computer output, explain multilinearity, describe the types of multiple regression. Actually, define a problem, specify problem, collect data, etc. Use you have to for making a problem in regression model. There are two types of actually simple and multiple. There are two types of regression analysis model. Actually, one is simple and other is multiple. Okay. In these two, first the Pearson correlation measures the degree to which is set of data points form a straight line relationship. Actually, in correlation, we have studied about the relationship between two data. Okay. Now we are try to determine the measure the degree to the degree of relationship. Okay, impact of relationships in this regression analysis. So regression is a statistical procedure that determines the equation for the straight line that best fits the specific set of data. Okay. So regression is a statistical procedure that determines the equation for the straight line that best fits a specific set of data. Now, any straight line can be represented by an equation of the form. There will be independent variable x and dependent variable y. So this is the equation of a straight line, and this can be represented by a regression line, where a and b are the constants. The value of b is called the slope of constant, and that determines the direction and the degree to which the line is titled. And the value of the called a value is called the intercept, y-intercept. Okay. And that determine the point where the line crosses the y-axis. Actually, you must know from our earlier a and b are the constant. A is the constant term and b is the slope. And the a is the actually the term which is called y-intercept also, and b is the actually constant, and this is the also uh, slope which make the angle with x-axis. Suppose this is the line, there are in x-axis, and this is the y-axis, the grade point whatever is. Okay, this is the set scores in any subjects, set a score SAT. Okay, so this is the scores for start from 420 and end with 700. So for individual set a score, we get the grade point. Okay, so there are more and points, and actually this whole points. Okay, we are trying all the points to make in a linear way. Okay, uh, just if we joined this the if we join the all linear points, suppose this is the linear, and this is the all full linear, that means maximum uh, we are try to the points make the linear. Okay, just joining this we get this straight line, and in this straight line some are this side, some points lies in this side, and some other points are lies in other sides. Okay, so actually all points try to linear with this line. Okay, this is the linear regression, and you have to analyze how the degree of linearity of this data. Okay, so this is the actually straight line, and we got from what, using this data along the x-axis set scores and along the y-axis grade point average. So using this data, all points are try to be near the straight line. Okay, and we have, this is the cluster of points near the straight line, and this is called linear regression. How well a set of data points fits a straight line can be measured by calculating the distance between the data points and the line. The total error between the data points and the line is obtained by squaring each distance and then summing the squared values. Again, this is the condition of regression analysis in actually for linear integral. The regression equation is designed to to produce the minimum sum of squared errors. Actually, this is the linear regression line, and A is the constant term and B is the slope, which makes the angle with x-axis, and A is the y-intercept. So B can be written, this B can be written as, okay, as P divided by SSX, and where A equals to, this is the actually, we'll try to solve this. This is the also line which cuts y-intercept, this y-intercepts, and this is the y-intercepts, and this is the curve y equals to x plus 4. 4 means what? C equals to 4 here. C equals to what? 4. So y-intercept is 4. Understand? This is the curve y equal to x plus c. C equals to 4. A equals to 1. Okay. 1 means 45 degree. 10 45 degree equals to 1. This is why angle will be 45 degree. Okay. This is the actually introduction of linear regression and regression analysis. So actually, what is the regression? If the scatter diagram indicates some relationship between two variables x and y, then the dots of the scatter diagram will be connected, concentrated around a curve, and the curve is called curve of regression. Okay, in previous slide we saw there are different dots and they make a curve. Okay, so this is called actually curve of regression. And regression analysis is the method used of estimating the unknown values of one variable corresponding to the unknown values of another variable, because there is a straight line y equals to x plus b, and wait. So line of regression, when the curve is a straight line, it is called linear regression. Okay, if the curve is linear, then this is called linear regression. A line of regression is the straight line and which gives the best fit in the least square method. Okay, again, regression will be called non-linear if there exists a relationship parabola types, okay, or hyperbola types, other curve other than a straight line, then between the variables and under consideration, then this will be non-linear regression. Okay, this is y equals to a plus bx. Okay, this is the constant term and b is the slope, right? We can draw this straight line, using this. Okay, this is the linear regression, and we have proved y equals to a plus bx. Y bar means what? Mean. We can use this straight line for mean also. There are two variables, one is dependent variable y and other is independent variable x. So relation between two variables is a actually function, but for every value of x we get another value of y. So this is the straight line, remember it. And this is also true for mean y. Mean y bar equals to a plus bx bar. And using these two relationships, actually we have derived r. Actually r equals to what? You must know r equals to what? In our previous lecture, r was correlation. Okay, correlation. are equals to summation xy divided by covariance square summation xy divided by square root over summation x square root over summation y square, and this can be written as this. And this is the sigma x, this is the variance of x, and this is the sigma y, variance of y. This is also can be written as n is the number of total number of frequency. So the slope of a regression line b can be represented as r sigma y divided by sigma x. Sigma y equals to what? Variance of y, and this is the sigma x equals to variance of x. So has the regression line the equation of line the equation to the line of regression is y minus y bar equal to r sigma y sigma x x minus x bar. This is the actually regression line. And similarly, the regression line of x on y, okay, will be this. This two is the formula we have used in our solving example. We have to use these two formula. This is the regression line of x, and this is the regression line of y. Okay, and this is the regression line of x. Okay, these two, and here byx equals to what? R sigma y by sigma x, and bxy equals to r sigma x divided by sigma y are known as the coefficient of regression. These two are the coefficient of what? Regression. Understand? If byx, then sigma y will be numerator, and if bxy, then sigma x will be in numerator. So these two combinedly gives what? Coefficient of regression. Remember it. And if we multiply these two, we get this equals to what? R square. R square means what? Correlation coefficient whole square. Okay, R equals to what? Correlation, this correlation. Okay, and this is the regression coefficient of regression. Remember it. B means what? Regression of coefficient. Okay, if theta be the acute angle means what? Less than 90 degree, more than 0 degree, that means 60 degree, 30 degree, etc. are called acute angle. Between the two regression lines, the case of two variables x1, then show that this is the condition tan theta equals to for finding angle using the variance and correlation coefficient. So r sigma x sigma y have their usual meaning. Explain the significance when r equals to 0 and r equals to plus minus 1. Okay, line are given, actually line of y are given this, and line of x will be give this. Okay, where m1 means slope, r into sigma y divided by sigma x. This is the slope whole m1, and this is also slope m2. Okay, so tan theta equals to what? We know formula. Tan theta equal to m1 minus m2 divided by 1 plus m1 into m2. This is the formula. Just putting m2 and m1, this m1 m2, we get this is the tan theta equals to. Okay, if r equals to 0 here, then 1 by r. If r equals to 0, then there is no relationship between two variables, and they are independent on the putting the value of r equals to 0 in equation 3, because we get what? Tan theta equals to what? Infinity, or theta equals to 90 degree. In tan 90 degree, this is undefined. Okay, if r equals to 0, 0 divided by something by 0, something by 0 means what? Infinity. This become what? Infinity. So tan theta equals to infinity, what? In how many degree? Theta equals to 90 degree. If 90 degree, the tan will give what? The value? Infinity. So the lines 1 and 2 are perpendicular. This will, the condition will be what? Perpendicular, 90 degree angle. This is why. If r equals to 1 or minus 1, any one, then the putting the values of r, that means 1 r equals to 1 or minus 1 in this equation, we get tan theta equals to what? 0, or theta equals to what will be 0 degree. That means parallel. Okay, so line 1 and 2 coincides. Coincides means what? Parallel lines. The corresponding between variable is perfect. Understand everybody?
Yes, sir.
Actually putting r equals to 0, first we get undefined 90 degree. 90 degree in how many degree? 90 infinity in how many degree? In 90 degree. This is why they are perpendicular, and this coincides. This means parallel. If the coefficient of correlation between two variables x and y is 0.5 and the acute angle between their lines regression tan inverse this, then show that sigma x equals to this. However, r equals to given and theta equals to also given 3 by 5. That means tan theta equals to what will be? Only 3 by 5. Okay, this can be written for inverse trigonometric function. So tan theta equals to what? We know this. This is the relationship from this. Okay, we have proved this relationship. Okay, so using here putting r equals to and tan theta equals to this, you get after a calculation cross multiplication we get this. Then this is a actually solving for sigma x and sigma y. Okay, we get two values, sigma x minus 2 sigma y equals to 0. That means sigma x equals to 2 sigma y, uh, and another one is 2 sigma x minus sigma y equals to 0. That means sigma x equals to half sigma y. Okay, this is the actually values of sigma x. This is the actually acceptable, and this sigma x is 2 times. This is why this is not acceptable. Sigma x and sigma y cannot be 2 times. Okay, so we have showed this. We have to show this. This is why this is the acceptable condition. Now find the correlation coefficient between x and y when the lines of regression are this. These two lines are given. Okay, then you have to find out the correlation coefficient. The line of regression of x and y be this equals to 0, then the line of regression of y on x equals to this. From these two straight line, x equals to what? 9 by y minus 3. That means bxy equals to what? 2 by 9. Regression on x. Okay, on x will be this. So from another line, y equals to this can be written as y byx equals to what? Half. Just slope. Okay, and this is also slope. Now r equals to what will be? Square root bxy and byx. This is the formula. And r is the correlation coefficient, and b is the regression coefficient of regression. Okay, remember it. But after multiplication we get 3 by 2. This is the greater than 0, which is not possible because correlation coefficient can never be greater than 1 and less than -1. So our choice of regression line is incorrect. Again the regression line of x on y, this, and the regression line of y on x is this. Then can be written as x equals to mx plus c, then m equals to what? 2. This is the bxy because regression of y on x. Okay, again from another equation, y equals to mx plus c, m equals to what? Byx, 2 by 9. Then after multiplication you get only 2 by 3. Hence the correlation coefficient between x and y is 2 by 3. Okay, this is less than 1. This is acceptable. Again similarly 17 example, you can try to understand this. Okay, okay, the two regression equation of the variables x and y are given. X equals to this and y equals to 11.64 minus 0.50x. We have to find out the mean of x and mean of y and correlation coefficient between x and y. This is the given equation 1 and 2 are the given regression line. Okay, as 1 and 2 passes through x bar y bar, we can convert it into what? Mean x bar and y bar. So solving this we get as before example by cross multiplication method, x bar equals to this and y bar equals to what will be this. You have to do this. Okay, otherwise marks will be deducted. So from equation 1 we can write r sigma x divided by sigma y. This comes from what? X equals to m. This is the slope. Okay, this is the slope. 0.87 is the slope. Again from equation 2, sigma y divided by sigma x. Equation 2, this is the actually what slope for y. Okay, and this is for x. First equation will give on x, regression coefficient on x, remember it, this is by sigma x will be in numerator, and for y will be sigma y will be what in numerator, and y equals to, this is the slope, and for x this is the slope. Okay, as sigma x and sigma y are always positive, so r is negative. Multiplying 5 and 6 we get this 2 multiply will give what, r square equals to what will be, r equals to plus minus this. Similar process, example 20. Example 20 will give what, similar process, mean we can write the regression equation like the regression equations are 1 and 2, this is given equation. Okay, so we can calculate x bar and y bar. X bar means what, mean, and y bar means mean for y data, and this is the r equals to what, correlation coefficient. So the coefficient of regression of x, correlation of coefficient of x on y, x on y will be sigma x divided by sigma y. Okay, r into, and the again from correlation coefficient of y on x, that means sigma y divided by sigma x. So from these two, from line 1 will give what, coefficient of y, and from 2 coefficient of x. Understand everybody? So from 3 and 4, after just multiplying we get r square equal to what, this is the actually correlation coefficient. Now from equation 3 and 4, sigma x and sigma y are always what, negative, so r is also negative. Sigma x and sigma y are always what, negative, this is why r will be also negative. To find out x bar and y bar, we have to solve equation 1 and 2. Okay, by what, by cross multiplication method. Okay, making it in x bar y bar and y bar x bar. Okay, then solving by cross multiplication method, we get what, as previous example, x bar equals to 6, y bar equals to 1. Now show that the geometric mean of the coefficient of regression is the coefficient of correlation. This is actually theorem. Geometric mean, we have to find out the geometric mean, and the coefficient of regression is the coefficient of correlation. So coefficient of regression are, we know, are coefficient of regression on y. Okay, r into sigma y divided by 7, and on x will be what, r into sigma x divided by sigma y. So geometric mean what will be, square root over this 2 multiplication. Okay, just multiplying, just it will give only r. So the it will be what, coefficient of correlation. Very small theorem. So another, prove that the arithmetic mean of the coefficient of regression is greater than the coefficient of correlation. Arithmetic mean you have to find out. We already known coefficient of regression on y will be this, and coefficient of regression on x will be this. So we have proved that arithmetic mean is greater than r. We have to prove this. Arithmetic means what? This plus this divided by 2 greater than r. That means half this plus this. So taking common r, r will be cancelled. So this great minus 2 greater than this, and this can be written as how we get this actually, by what, by taking LCM, least common multiple, we get this this inequality, and this is actually formula a minus b whole square formula, which is true. That means for this difference always or positive or negative, anyone may be, this square will be always positive, so it is true, this theorem is true. Okay, the arithmetic greater than the coefficient of correlation. Now main example, example 24. In a study between the amount of rainfall and the quantity of air pollution, remove the following data were collected. The rainfall is this, and the pollution will be this. Suppose this is the daily rainfall is x. Okay, and pollution removed will be y. Understand? This is the serial number, and this is the xy, just multiplication, and this is the x square. Okay. Now find the regression line of y on x. We have to find out the regression line of y on x. Let y equals to a plus bx be the equation of the line of regression on of y on x, where a be the constant. Y equals to what? This is actually, there is a printing mistake. Y equals to, this will be y equals to a plus bx. Okay. This is the regression line of y on x. So this can be written as summation y equals to what? How many? There are n times summation. Okay. How many data? N times. Okay. So na plus b summation x. Okay. This is given from table summation y equals to what? Summation y taking sum all. Okay. This is the summation. And n means what? How many data here? 8 data. Okay. 8. B equals to what? B equals to summation this, x summation x what? This 37.5, 37.5b. So and we can multiply x on both sides. Okay. Both sides of this line, y equals to x plus bx. Multiplying x on both sides, we get summation xy equals to a summation x b summation x square. Just putting these values here, summation xy summation this 453.82, and a plus summation x what? This 37.5, and summation x square what? This 188.01 b. After solving this, we get a and b. Okay. Solving 1 and 2 equation, a and b. This. Now the equation of the line of regression on y can be written as, regression of y on x can be written as y equals to what will be? A plus bx. A means what? 15.49, and b equals to what? Minus 0.675. This is actually result. The regression line of y on x. Remember it.
আমাদের আরেকটা ক্লাস আছে স্যার।
Okay, just 5 minutes. Now example, another example 25. Find the correlation coefficient and regression lines for the data. This is the x data and this is the y data. We are finding the relation between x and y. So this summation x and this is summation y, just taking addition. So x bar will be what? Summation x divided by n, and this will be the 3, and y bar will be also 5. So this is x data, y data, and capital X what? This is the deviation x minus x bar. Okay, this is x minus x bar, and this is y minus y bar. X square and y square, capital X square and capital Y squares, xy data. Now correlation coefficient are equals to what? Just putting in this formula in previous lecture about correlation coefficient, we must know. Just this will be 0.8062. This is the perfect correlation. Okay, positive relations also, and are equals to what? Summation xy divided by n sigma x sigma y. This is the relation between actually regression. Sigma x is the variance of x and sigma is the variance of y. So we can write this. Now slope of regression line of y. Slope of regression line of y. This is the actual formula. Slope of regression line of y on x will be summation xy divided by summation x square. Just putting the values. Slope of regression line of x on y. On y will be summation y square. On x will be summation x square. Remember it. Half. So the equation will be what? Equation of y on x. Y minus y bar. Slope. Slope means this. X minus x bar. This. We get this is straight line. Equation of regression line of x on y will give x minus x bar into slope. Slope means what will be? This one. This is the straight line. Just putting x equals to the mx plus c types. Similarly, example 26, we can solve. There are actually 7 data of x, 7 data of y, and n equals to 7. This is y. Then x bar will be sum of x, summation x divided by n will give 10. Y bar will be 22. So capital X equals to what will be? X minus x bar, and capital Y will be y minus y bar. Similar process. We get capital XY this, x square this, y square this, correlation coefficient will be this. This is the negative correlation coefficient. So r sigma y sigma x equals to what will be this? This means what? Square root over summation y square summation x square. Just putting these values, we get this. And this is the regression of y on x. This is the regression of x on y. Remember it. These two formula we have to remember. We get these values. Now the equation of line will be y minus y bar r sigma y sigma x. These values and these values same. Okay. And for another line, equation another line, x minus x bar equal to rx. If they are x in left hand side, sigma x will be in numerator. If there are y, and sigma y will be in numerator, like this. Okay. You have to remember this formula in this way. So this is two lines. Hence the equation of the line of regression of y on x will be this, and the line of regression of x on y will be this. Just we are finding the regression line. 27 will be homework for you. Similar process. You have to okay. Today is the ending of the first part of regression analysis. Try to do it at home and practice it. Okay.
Yes, sir.